Right, so in this video I'm going to go through coroutines. I've started a new 2D project and I've got some prefabs to talk about. So I made these two prefabs, enemy and enemy 2. They only have one script on them and that script just moves them in a direction which I've down because I put -y. They'll just fly off the screen when they're made. There you go. And because I want to spawn them in waves, there are many ways to do this, but one way is just to make a wave. So I just made a wave. That's wave 1. That's wave 2. That's one way of doing it. So I've made two prefabs with the prefabs in them. So they've got wave 1 and wave 2. Okay, nothing too crazy by doing that. So now I've got a script on my level spawner, which is going to, which at the moment is this. And it takes an array of game objects, and I'm going to drag my two waves in there. I'm going to just do 2. I'm going to put in prefab. I'm going to drag in wave 1, drag in wave 2. And so now it's going to spawn them, but I want them to go, I want it to go wave 1, wave 1, wave 2, wave 2, wave 1, whatever. Imagine I've got more waves, but I couldn't bother to make more waves, but let's assume I've got a selection of waves in there, and we want to do them after a certain amount of time. So the best thing to do is to do a coroutine. So I need to create one, basically. That's as simple as that. And what a coroutine is it has a couple of things, but it allows code to run and then give up control until later. So here's an example. If we did a while, let's say we did something like this, for in I equals 0, I next enemy is I plus 1, spawn the wave. It would spawn all the waves. If we put a delay in there, say we did, I know it's not how you do it, but say we did spawn wave 1, spawn wave. Actually, you know what? I'll do it. I'll actually do instantiate bracket and then enemies I. Okay, brilliant. And then save it, and then we'll see what happens if we do that. Now, what actually happened was we've got wave 1 and wave 2 at the exact same time, right? And they also spawned in the wrong place, but let's not go into that. They wave 1 and wave 2 at the exact same time, so that's not good. So let's just quickly fix the transform, which is going to be game object.transform. And then that will spawn where my spawner is. Well, I did, you can see that. But they're all spawning at once. Both 1 and 2 are spawning at once. So you might think, oh, put a delay in there, blah, blah, blah. But that actually wouldn't help, because what would happen is it would just pause the program while it spawns them, because this code will execute until it's completed. Okay, what we want is a way to execute code and then give up power and come back later on at a time. And this is basically done with a coroutine. I'm just going to comment that out for now because we can use some of it in a minute. We can use that line. But hey, so we're going to create a coroutine that's going to do that. Think of it like a cutscene. So first of all, we create this sort of method with IEnumerator. I'm going to copy and paste it as I always do. So it's IEnumerator, and the name of it, we'll call it spawn level 1, whatever, or spawn level, whatever. It takes no parameters, and there we go. So how it works is, moaning for. Oh, doesn't all yeah, doesn't matter. Don't need to return. We've got return stuff. That's why. I'll just put the yield return now. Now, I'll give you a different example. Let's do. Actually, let's put this in. Let's just put this in, and then this because this could be one way of doing it. Now, you might think that's no different. And then how do we start it? Well, we do it with what's called start coroutine, and then the name of it in yeah, so spawn level. Okay, and you might think this is going to be no different to before. It's going to spawn them at the same time, but we can do this thing called wait, a time delay, and we can wait for a certain amount of time between things. If I do yield return new wait for time, okay, and then I can do something like, I don't know, let's do 5 seconds between. And then it will spawn the first one, and then the second one 5 seconds later. Here's wave 1. There's wave 2. Okay, so you can see that now. Obviously, I've done this with a for loop, and probably what I would have done, because they all want different delay times between them. You know, you probably wouldn't have a for loop. You'd probably have you know, instantiate enemy 0, wait for 4 seconds, instantiate enemies 1, then we'll have a wave 1, and then a wave 2 for 3 seconds later, we'll have another wave 1. You know, but now we've got it's going to go 1, 2, 1 with different timings in between. There is no actual need for this last wait, but you know, it wouldn't have done anything. It would have just waited 3 seconds and then finished, and it wouldn't have made any difference to the game or code or at all. There you go. So now we're going to have 1, then 2, and then 1. All right. Now this can be done also with invokes, and I will show that because a coroutine is often compared to an invoke. So I could, for example, do it a different way. So let's not do the coroutine, and let's just do like we make. Yeah, it's not. I don't know. I'll just do like private void spawn. I could call it spawn 1, I suppose, or spawn enemies, something like that. I think I'll call it spawn. I don't know. Yeah, spawn 1, and then that will instantiate object 0. That should be spawn 0. Spawn wave 1. Then I do the same. Spawn wave 2. And then you could do, you know, spawn wave 1, invoke, spawn wave 1 in 0 seconds. So straight away it's going to spawn wave 1, and then spawn wave 2, 4 seconds later, like the delay. And then we could also then do that again. That'd be 7 seconds because that's together. Now you might notice the annoyance of invokes in there's no way of putting parameters in, so that's another reason why coroutines can be a lot better. But I do sometimes use invokes, so I just want something to happen sort of 2 seconds later and then something 1 second after. It's a lot easier maybe than creating a coroutine. But that will basically do the same thing with invokes. An invoke will execute a method after a certain amount of time. Can be good for looping, like enemies shooting and things. Get them to invoke their own shot, and there is cancel invoke. Yeah, so I've sort of made the exact same thing. There you go, using invokes. Some people like that way, some people don't. And if you wanted to do a thing where it was like, you can't send a variable in to here, but I could make a private variable here called like current wave. So, you know, and then I wouldn't have to have different, say I had 10 different ways. I could make a private in called wave, set it to 0. And then just do spawn wave like this. Wave equals 0, or wave equals 1. You could even make a 2, and then it would do it whatever. But the only thing with that is you've got to be careful they don't do it out of order, because you know that needs to go off before that. But yeah, I mean, coroutines are probably better for this for that exact reason. That's why I wouldn't use something like this. Definitely a coroutine. There you go. Now in the next video, I'm going to use a more advanced coroutine to do a cutscene in a program, but that's going to need events, so I'm going to put that into a different one. But yeah, that's what a coroutine does. So I've very quickly knocked up another sort of example. This is a script to fade something. So yeah, just show you the object. I put it on a square, a sprite with a sprite renderer, and inside it you've got the alpha of the sprite, which starts at 255. And basically what I'm doing here is I'm getting access. So I'm making a coroutine that executes when I press the F key for fade. So it gets access to the color from the material here, renderer. While the alpha value is greater than 0, we're going to reduce the alpha by time delta time. So it's going to take 1 second to fade. Okay, if I wanted 2 seconds divided by 2, you know. Then I'm clamping it at 0 so that it doesn't go below 0, basically, as well. I don't really care about the high number because it'll start high and go down. So I don't want it to go below 0. And then I'm just, then I set the color and then I yield return null. So if I didn't have that, it would fade immediately to zero because this loop would just keep happening in one frame. It wouldn't go on and do some other code. That yield return null allows other code to happen, and the next update it will do this again. And the next update it will do this again. So that's the beauty of a coroutine. So it allows you to have things that can sort of execute and not interrupt other things. Quite handy. Another one that Unity recommends, a sort of handy one, and I'm going to show you it. I'm not going to write it, but you could use a coroutine to continuously check for something like a proximity check. So here it's got like this tells you if you're if you're near something or if you're near one of the enemies, right? But if you were to run this proximity check every frame on every enemy or whatever, it might be slow. So what you could do is do a coroutine. That for is just like doing while true. Apparently, some people prefer to do a for loop with double semicolons as opposed to saying while true. That's loops forever. And then if the proximity check, do whatever you want to do, and then yield return wait for 1/10 of a second. So it'll do the check, but only every 1/10 of a second, which would significantly increase it if you had lots of objects. And if you had lots of objects in a game, you very much need to do these sorts of things to slow down, well, to speed up, sorry, the execution, because you don't want to be doing that for every object, every frame. Yeah, there's more to coroutines. I'll have a look at the next one about doing a cutscene. Maybe watch that one.